In this lesson, we are focusing on how to solve equations with one variable that contain more than one operation. So remember our order of operations. Order of operations, we can remember it by thinking about please excuse my dear Aunt Sally. When we are simplifying an expression, like if we had 4 plus 5 times 2 minus 8 squared, we would use PEMDAS to help us figure out what to do first, right? There's no equal sign in an expression, but you follow order of operations when you're simplifying an expression. So you would simplify with the parentheses first, and then you would do the exponents next. Then you would do multiplication and division in the order that they appear, and then you would do addition and subtraction in the order they appear. So we follow order of operations when we are simplifying, right? That's no equal sign. However, when we're solving an equation, now you have an equal sign, you have to undo what was done, okay? So we have to work backwards. When you are solving, so when you see an equal sign, you actually start with addition and subtraction, and you undo that first. Okay, so remember that. I know you've learned this. We're going to go through these. I won't have time to do every single problem, but hopefully it helps to refresh those skills. Before I get started, I do want to say I'm not going to have room to show the checks on the board in time in this video. However, I strongly recommend that you still check your answers. Equations are awesome, guys, because there's no reason to miss an answer because you can plug your answer back in and make sure it works. Make sure it makes the equation true. So I'm not going to show the checks today, but you should be checking, at least in your head, if you're not physically showing it on paper, to make sure your answer is correct. All right? So in number 1, I can see my variable is A. Think about it. What is happening to your A? So right here is my A. I can see that A is being multiplied by 4. It's also having a 10 added to it. Undo PEMDAS. So we start with any addition or subtraction that you see. So that would mean the plus 10 is what needs to be undone first. I would subtract 10 from both sides in order to undo that. When I subtract 10 from both sides, they would cancel over here and I'd be left with 4A on the right, and 18 minus 10 over here would give me 8. Now all I have is the multiplication, and we did this yesterday, so we would just divide both sides to undo that. Dividing by 4 would cancel out those 4's, and I'd be left with A equals 2, or 2 equals A. Keep everything lined up. Check your answers. If I plug this back in, 4 times 2 would be 8, and 8 plus 10 would give me 18, so it does check out. Try 2 and 3, pausing the video. I will warn you, number 2 does not work out to a whole number answer. That is okay. Fractions and decimals are answers, can be answers too. And number 3, you have to remember your fraction skills. So try 2 and 3, and then press play, and I'll talk about them a little bit. So hopefully you have tried these on your own. It's best, you will learn better if you try some on your own and then go over with me. In number 2, I would add 2 first. I'm doing addition or subtraction first. Then I would divide by 5. Some of you would panic maybe when you see this. Wait a second, negative 25 is not divisible by 5. I must have it wrong. I'm going to say that if that happens, I do strongly recommend that you check your work. You might have made a mistake. More common or more often, we do typically get whole numbers or integers as our answers, right? However, in this case, negative 29/5 is the answer for T. Fractions and decimals are numbers too, so don't be afraid of that happening. Just be cautious. Check your work when that happens because you might have made a mistake. And number 3, just because there's fractions, I'm still subtracting 3/4, so start with the addition or subtraction and undo that. I would add 3/4 to both sides. Now, you have to remember how to add fractions here. 5/4 and 3/4, you add the numerators, keep the denominator. So you get 8/4. I would never leave 8/4, guys. Think about it. 8 divided by 4 is just 2. So that's how I got the 2. Now, I can see that y is being divided by 8, so I multiply by 8 on both sides, and I get 16. Again, please check your work to make sure you're getting these equations correct. Okay, so let's try the next one together. Number 4. R is being multiplied, and R is being added. What do I undo first? I undo addition. So I am going to subtract 3/4 from both sides. Now this subtraction with these fractions is a little bit more work. Why? Because these don't have a common denominator right here. So I'm going to have 2/3 R equals, and I can see that they don't have a common denominator right away. Remember, you have to have a common denominator in order to add or subtract fractions. So I could easily make this 4 a 12. I would have to multiply it by 3. But I have to keep the fraction equivalent to my original fraction, so I'm going to multiply the top and the bottom by 3. I'm going to show this work. So I would have 7/12 minus 3 times 3 is 9, and 3 times 4 is 12. Now I have 7/12 minus 9/12. So I'm just simplifying this side right now. 2/3 R equals 7 minus 9 is a -2, and I'm keeping the denominator. -2/12, that can be reduced, that can be simplified. So I would simplify that before continuing to solve your equation. And this brings up a good point that I'm going to talk about for problem number 6. Always simplify as much as you can in your work. If you can simplify first, do it. So -2/12 can be reduced by 2, and I would get -1/6. Now I'm ready to continue solving. So look at all of that work that I did in blue that was just really simplifying. Now I'm going to go back to inverse operations. The opposite of 2/3 being multiplied by R, remember, would be dividing by 2/3, but I don't like dividing by fractions. We're getting a little older now. We can understand that that's the same as multiplying by the reciprocal in order to get that to cancel. So I would multiply by 3/2 on both sides. These cancel out, and you're left with R equals -1 times 3 is -3, 6 times 2 is 12, and I can simplify that fraction again. So I'm getting R equals -1/4. I'm going to do number 6, and then you're going to come back and do number 5. In number 6, you have parentheses. So we do undo order of operations. So you might think, oh, well, I do the parentheses last. But you really have to look at the set of parentheses like it's holding something up outside of it, right? So why do we have the parentheses? What is the point of them? Well, I can see that we have this minus sign out front, which is really like a -1. Okay, we are really distributing this negative sign, or we are distributing a -1 times that. So you can think of it as distribute the minus. You can think of it as distribute a -1, but it's really the same thing. So the reason we have those parentheses is because everything inside needs to receive whatever was out front. So do that, distribute. I would have 10y minus 4y minus 8 now equals -20. So remember how I just said a minute ago, simplify whatever you can first. Remember to combine like terms. Like terms are terms with the same variables and the same exponents. So I can see here that 10y minus 4y have the same variables. I would simplify that first. 10y minus 4y is a 6y. Keep the -8, keep the -20, keep the equal sign. Now this equation looks just like the other one, so undo, finish solving by using inverse operations. I would add 8 to both sides first. That gets me 6y equals, this is a -20 plus 8, so that gives me a -12. Then I would divide by 6 on both sides, and I get y equals -2. Try number 5 and then press play to go over it. So hopefully in number 5 you combine the like terms. 8x minus 5x. Remember to always look to the left of the variable, okay? So you have to, when you're combining, don't just see 8 and 5 and think, okay, 8 and 5 is 13. Because we have an 8x and then we actually have this minus 5x. So you really need to look to the left of every term and make sure you pay attention to the signs. 8x minus 5x gives me 3x. Now I can solve using inverse operations. So if you didn't get that right, pause and take a look at that work here. Number 7, I want you to try on your own as well, and then I'll reveal the answer. So pause if you haven't done number 7 yet and try this problem. Going over number 7, you have to distribute the number 4 in front first, just like we distributed that minus sign or that negative sign. After you distribute 4, you multiply by 4, you can combine like terms. Look to the left, so notice how I underlined this plus sign. If there's nothing in front of the 4, think about it. What kind of 4 do you have? A positive. So we would get a 7x. Inverse operations tells me to add, or undoing PEMDAS and using inverse operations tells me to add 8 first and then divide by 7. Looking at number 8, you're going to have to solve this equation first and then find the value of 3x. So when solving, I would subtract 4 from both sides. I would have 2x equals a negative 28. Then I would divide by 2 on both sides to get x by itself, and I get x equals negative 14. Okay, so here's the thing, guys. On this one, it didn't ask you to find x. It asked you to find the value of 3x. So we now need to find the value of 3 times x. So all you do is take your answer and multiply it by 3. If I asked you to find the value of 4x, you would multiply it by 4. If I asked you to find the value of 1/2 x, you would multiply it by 1/2. Either way, your answer here is negative 42, not negative 14. Remember that negative 14 equals x, but I asked you to find the value of 3x. So it's asking you to do one more step. I went through that fast, but I want to get to this word problem again. Please remember that you can ask questions in school about anything you don't understand. Okay, so I have the work up here for this last part because I'm running out of time for the video to be under 15 minutes. So I'm going to explain it, but you can ask questions in school. So I define my variable, and the thing that I have to think about is that however much she saves from like eating lunch, then you have to take away what she had to spend just to join the club because that takes away from her savings, right? And she ends up with her total savings that way. Think about it. If you paid $20 to join a club and then you got a discount on going to the movies and you ended up saving $50 total on going to the movies, you didn't really save $50 because you had to pay $20 to join the club, right? So you have to take that initial spending amount off of your savings. That's why I came up with this equation. It's $250 each time she eats lunch that she's going to save, but she had to put this money in to start. This was like an investment. So you have to take that away from your savings to get her total savings of $1,255. Okay, that's why I set the equation up that way. Then using inverse operations to solve, I can see that I would end up with t equals 21. So don't forget to label your word problem answer of T stands for 21 times that she's eaten lunch, right? To save $1,255 total. Please remember you can ask questions. I know I went over that very quickly, but think about how if you have to spend money to join the club to start, that takes that away from the savings, right? So she had to take away the $39.95. She really saved $52.50 on eating out, but after spending $39.95 just to get that discount.